I would like to present this one is sharing a little bit about the sustainable energy management in UTM. Really, I hope you can see my slide on your screen, right? Okay. Are you ready, class?
Okay, Doctor.
Okay,
Doctor.
let's start. So last week we have learned on about the sustainable energy management system, right? How to set up and what's the responsibility for the energy manager and how the company can manage to put the energy manager in the position. And we have learned on how to set up the energy teams and remember the term of EAC, Energy Accounting Center, right? Okay, so the mapping on how this EAC manage on the operational, okay, head of EAC must be trained and understand what is going on under their supervision for the EAC and to map the what we call it the instruction log sheet etc to and reports the performance of EAC to the EMC Energy Management Committee. So under the EMC, so EMC chaired by top management and their energy manager involved to advise the EMC on how to move forward on the planning, on the whatever ECM, energy conservation measures that they put on the planning, budget management, staff training to get empowering the human resource part. Okay, so this one, what happened to UTM for the sustainable energy management practice? And our team is to towards dynamic and a smart campus in UTM. So after 5 years, we have about 21 buildings in UTM to cater on the SAM Sustainable Energy Management System. We have make it properly started from the planning since 2015. Okay, this one before this the Center for Sustainable Energy and Environment 2014 2020. So from the center this center have been converted to office and combined to the occupational safety and environment sustainability. So in UTM, we have EAC here as the Energy Accountability Committee and EMC, and the other part is the Executive Council. So energy manager will report to the Energy Executive Council, which is consists of all the top management in UTM, include a dean, okay, assistant, vice chancellor, deputy vice chancellor, and chaired by vice chancellor. Okay, for the EMC, EMC will be chaired by the director of this office. And the EAC that's representing all the buildings, 21 buildings in UTM main campus especially. Okay, so I have been seconded here to be manager for the unit and the energy manager for the UTM. Okay, this one is energy policy for UTM. So in energy policy, remember that we have two kind of energy policy. One, the parts one is one page, the commitment from the top management and must be signed by the top management. And here, energy manager, energy policy in UTM has been signed by Vice Chancellor Datuk Wiraraha, and we have put the commitment towards a continuous improvement, cover all elements of energy types we should not consider only electricity, but we managed to put the performance of the water, fuels for the transportation, etc., that we use in within a UTAM operational condition. Okay, so the third one is commitment to follow the regulation, and we state that must have the regulation and clearly state the Acts of Electricity Supply and EMER, EMER 2008. And for the financial one, to put the commitment to follow the GGP, Government Green Procurement, for any kind of the purchasing procedure, we follow the Government Green Policy, which is have another parts of the um, procedure to buy something with the consideration of the 40 elements under the GGP, okay, with um, consideration for the procedure on how we can buy or we can put any tender or any procurement that we have for the certain budget that we need to buy equipments or another assets under UTAM, and we follow the government green procurement. And the last one is provide resource. Of course, in the energy management, we have a lot of to do, and we need to prepare our resources. For example, to manage the energy, to manage the EAC, and to manage in every level that we have. Okay, we need the technical person. We need people who understand what is going on under the sustainable energy management, so that this implementation of sustainability practice will be a long life, okay, and a robust, and I think that's a good point for the UTEM to as the succession plan. So human resource must be ready with a proper plan, with a proper budget to come up with the plan for the to support the objective of this sustainability program. Okay, let's move to this slide. Okay, this one, energy management metric, right? So previously, for the baseline, okay, for the baseline, this one is the status before the sustainable energy management system is introduced, was introduced in UTAM. That this one is we have drawn it for the first startup during in that story. I have told you last week. UTAM before this, we have no energy management proper for the energy management, and there is the policy, unwritten policy set, and there's no commitment from the top management. That's the status before this SAM was introduced in UTAM. So yeah, that is status. Only low cost measure taken at that time, whether any proper management on the marketing. People doesn't know that's the existing of the EE program, right? So this one is the status at the time. So after that, what happened to UTAM? After SAM's setup, that's the improvement for the policy, and Vice Chancellor have signed the policy, but no active commitment from top management, because at that time, there's no involvement of the Executive Council in this energy management. Okay, so we have energy team with ad hoc committee. There is the post for the energy manager, but doesn't have any kind of the committee at the time but we improve slowly and make it better year to year. Okay, that is the motivation. An information system, at that time there is the close information from the meter data. For example, bill we cannot present to anyone because of that's the secret, they declare as the secret document for UTEM, and I think that's not good. But we discuss and explain to the management that this is important to put the target reports based on the metadata, and then we need to present our clearly our status for the electricity, etc., to our staff. Okay, for the marketing part, etc. So the investment at that time, a zero investment. Okay, we put a zero, only a small number of investment maintained from the previous one. Okay, year to year we improve, and then for this year we target to achieve all this level 4 perfectly, inshallah. Pray for us to make it better for UTEM sustainability program. We have kind of IoT system now available in our system. We have upgrade chiller system, we have upgrade building management system, etc. So this one is the framework of SAMS in UTEM, phase 1, 2015-2016, which is the development phase. And after that, this is the 4 years implementation for the integration and sustainability. Okay, the EAC1 integrate to the EMC, the document of the energy management integrate to the university ISO, etc. That's the integration and sustainability program. We have continued to do a lot of things, a lot of program for the sustainability, especially to put the commitment from all the level, every single level in UTEM, from the support staff to the top management, and also from the student, MPP, etc. So after that, this one is this year is the phase 3. Yeah, they're starting for the phase 3, which is UTEM target to promote smart and dynamic campus. Inshallah, we are entering the phase that we very challenging to put UTEM in the other standard, in the other levels of the smart and dynamic campus, involve all kind of evolution, industrial evolution 4.0, etc. That's the good point for UTEM to move forward, to become one of the public university that have this infrastructure and have involvement of the energy management culture in UTEM. So this one is the 7 goals that has been introduced by our Vice Chancellor and the top management in UTEM. They put 7 goals to be achieved by all the staff and student to be moved together in this kind of the 7 strategic goals. And for my office right now, under the assistant vice chancellor development and facility management, we have this team, this tema, okay, a smart and dynamic campus, goal 6. Okay, this picture show the commitment of the Vice Chancellor, Dato' Wira, Dr. Raha, okay, Prof, very committed to achieve this goal within the 5 years, okay. So we as a UTEM, and we proud to be in the loops, to working together to achieve this short goals for the UTEM to be one of the among that achieve certain level in the ranking in the operation and the other aspect of the students and graduates of choice. Okay, this is the goal 1 until the goal 7. Okay, what is under Smart and Dynamic Campus? Okay, for the strategy initiative S4 here, S4, so UTM target to put UTM in the position of the UI Green Metric World Ranking top 50. Right now, we are in a number 109, 109. Okay, 109, and we strive together to put the effort to achieve by 2025 to be top 50 in the world ranking for the UI Green Metric. And the other part is about the energy sustainable strategy initiative 5 to achieve a 3-star goal standard for the ASEAN Energy Management Scheme by 2025, but to maintain the 3-star until 2025. For the current status, okay, UTM have achieved 1-star rating in 2016, and in 2018 we have awarded by this energy management gold standard for 2-star. Okay, after that we target for this year to get 3-star assessment, inshallah. Internet assessment will be held by May 2000 this year, and the assessment for the EMAS on the energy management gold standard 3-star 2000 this on September. Sorry. So why EMGS Energy Management Gold Standard? When we compare to ISO 15001, which is energy management, this one is the international standard. But for EMGS, that's the available kind of criteria to more specific measures about the other aspect. For example, motivation, budget management, budget spending, performance, etc. Compared to the ISO, only measure on the energy policy and the documentation. Okay, so what's the other else? So detail on the organization and management assessment, for example, EMC structure, EAC and SIT, energy target and plan. So all these things has been assessed by the EMAS, ASEAN Energy Management Scheme, to put the rating for us, started from the 1 until 2, until 3. So 3 is the full the higher achievement for the standard EMGS standard, but must start with the 1-star, not we can call this assessment once for the 3-star direct to the 3-star, but must started with 1-star, 2-star, and 3-star. It means that we have proper planning started from the 1-star until we got 3-star, which is the full star rating under the EMAS. And the other part is staff competency. So they measure the training need analysis, what's kind of the training that staff need to improve the level of competency. Okay, technology transfer for new equipment. So if we have the new equipment, what's kind of the technology transfer that we need from the outside to the inside, or we transfer our new, as the researcher in the university, we transfer the technology when we have new equipment or when we have new invention to teach others to improve their level of competency as well. Okay, for the organizational awareness, so that's the another parts of the assessment to measure the awareness of the organization, started from the support staff until the top management. Okay, when this assessment happen, they call several staff, and then they pick up randomly randomly. They pick up the staff and they ask several questions, and then that's the way they measure the awareness. So when our staff is all ready for this kind of the assessment, and that's a good result for this kind of the measurement for the organization awareness. So recognition, another part for the assessment is recognition of the EM to adopt a scheme to recognize, motivate, and we have our own motivation procedure or our own motivation scheme for the internal. Okay, we has award our EAC. That's giving the performance, and we have measured them in the star rating as well. Okay, for example, FKE have achieved 3 star in 2017, 2018. Okay, that we receive the recognition from the university as the practice for the good awareness of the energy management and the implementation of the policy, energy policy in UTM. Okay, these pictures show several activity that has been done in level of the top management, and for the sustainability, that's the succession plan. The for previous, the former Vice Chancellor Datuk Sharin to Datuk Wira Dr. Raha. Okay. That's the signing ceremony for the new appointed VC in 2019. Okay, all this in the training, training, and then we have done several programs to the outside for the um, community service. Okay, this picture presents the executive council. The picture presents the executive council meeting. Okay, this is the introduction for the energy mascot. We call it Tuah Energy. Tuah Energy. And currently we have a certified EMAS EMGS assessor, 2 person, include me. I have been appointed as the assessor for the energy management gold standard since 2015, and last 2 years have been upgraded to the lead assessor. Okay, for the certified energy manager under the EMAS, we have 32% and a registered RIM 14%, and the other certificate related to the energy management, which is a certified professional for the measurement and verification, we have 10% in UTM. Good. Okay, let's move to the another aspect. So process aspect, very important because it's involved equipment and operations. So how about the this process? We need to analyze of the energy use. Okay, without analyzing the energy use, we doesn't have idea on how we can drive this energy management practice in UTM. But with proper installations of the IoT system, we got to know every single building have their own energy profile, and the practice we managed to measure the performance of the energy management based on this energy profile, and we have prepare every single buildings in main campus ini with a single bill every month, so that they can measure their own performance as well. Purchasing and procurement, of course, we have as stated in our energy policy, we have to follow the government green procurement and to promote the 5-star rating of the equipment purchasing on the procurement side. So operation control, we have currently we have upgrade our bus system, which is building BCS or BMS, building management system. Okay, that's the automation for the operational of the bigger user in bigger energy consumption in UTM, which is air cooling system, air conditioning system. We have centralized chiller over here, but with proper management on the scheduling, etc., we manage to get more saving after this, inshallah. But currently, we have spent about 3.7 million, okay, to upgrade our BMS. So for the maintenance part, we have this assessment. We'll measure about what's the current status of the maintenance, the scheduled maintenance, corrective maintenance. Okay. So this kind of the innovation that we have in UTM. Okay, we have mark tape here, metric for the energy management in every office or building in UTM. We have measured on the documentation, investment, policy, reporting, motivation, that all the category must be implemented by the faculty or the office in within UTM. So we have measure on the performance every single building, and we present it during our assembly, staff assembly. So another thing is the IoT system here, and we have upgrade bus system details with the temperature, okay, BMS ni, with the temperature detail with the energy part, and also we put the filter sensor to cleaning and the integration to the maintenance part. If this dust sensor, if there is the dirty for the equipment, there is the detection for the status of the clean or dirty indicator on the system. That's really good for the maintenance guys and operation guys to monitor this equipment, and hope this kind of the operation will help us to improve our operational and maintenance part later. And is in-house development of the building smart billing. Okay, this one, the examples of the billing system. For example, this for the FKE. Okay. So what's the amount of the electricity in FKE? Close to 100K every month. Okay, this billing system we have presented to every single faculty, every single office every month. The status of the total usage for UTM, for the UTM, total UTM, and the percentage load opportunity or energy breakdown for every single office or faculty. Okay, for example, here FKE is represent 14% compared to the total energy usage in UTM. Okay, this one is the profile, also has been also presented in a bill. Okay, every month they can see this profile for the maximum demand and for the energy consumption. And we have IoT system to monitor this profile. Okay, for example, when we launch or we call it a program, shut down before you leave for the lunchtime. So we monitor. For example, here is a good practice when staff going to for the rest time, lunchtime, so they shut down their computer, okay, shut down, switch off the lighting, the office, okay. So we managed to get very good saving for the maximum demand and the energy consumption as well. And we know we can measure the status of the baseline, so that we can manage to put the effort to reduce the base load. Base load is the time, the off-peak time started from the 10 p.m. until 8 a.m. every day. So this one is the status, 29%, and can be reduced more and more so that we can achieve our target to be less than 20% later on. So what's the impact after 5 years SAM implementation UTAM? After 5 years, okay, you can see saving. So how much the saving? How much the saving after 5 years? Because the electricity cost is the top five, can be considered as top five operational costs in UTAM, include salary of the staff and the other operational costs. And this electricity cost can be considered as top five as the operational cost for the UTAM, because for 1 year we have spent about 7 million for the electricity bills, for 1 year every year. And with this program, after 5 years, we have saved about 6.4 million. Okay, and average of the saving for every year is about 18.7%, or in energy consumption for about 17,600,000 kilowatt hour. And with the CO2 emission reduction, 10,000 ton CO2. Okay, so remember, it was said about the 1 ton CO2. 1 ton CO2 equal to 1 bungalow house. So this time, after 5 years, we get to reduce the CO2 emission for about 10,000 ton CO2. And the BEI, Building Energy Index, from the baseline 222 to 145, and we target to be green campus, and with the BEI less than or improve to 130 kilowatt hour meter per year, square per year. That's the units for the BEI energy, Building Energy Index. So in order to promote a smart and dynamic campus, okay, as the practice to put no cost measure first, with the proper planning, and we target to have the no cost measure and low cost measure to the high cost measure. Okay, so within these 5 years, and we have target to spend for the high cost measure for about 7.5 million under the RMK 12 to retrofitting for the inverter chiller in FKE, FTMK, PPK. So under the project RMK 2012, this one we have received good news from the ministry that we have this budget after this. So inshallah, this project will continues our commitment to make it this campus more smart and dynamic for the future. Okay, the tips for the sustainable energy management system. So understand the policy and JD, job description, loyal with the policy that we have, get the right training and coaching, optimize channel of communication. Okay, champion team. So must have the dedicated office, dedicated team, dedicated that we call it them as champion team. The give the effort, give the idea. Okay, this champion team must be developed and synchronized between the office and between the level of the management. Okay, analyze reporting record, PDCA, plan, do, check, and action. So must have that kind of the philosophy so that when we have any problem, we come up with a discussion and we come up with the solution. And when we plan, we do and we check back all our plan during the implementation one, and we take the other action to improve or to enhance the performance of that. Okay, thank you for the that's the end of the chapter 2. I hope this one clear about the energy management, okay, for the chapter 2, and we continue the chapter 3. Okay, before that, any question? If no, we proceed to the chapter 3.
No, doctor. Everything is
No,
good.
right? Any
No,
opinion?
doctor.
Any opinion for us to improve the energy management practice in UTM? So if there is any idea, please come to my office or we can discuss further.
No opinion for now, doctor.
Okay, thanks for the response. Okay, we proceed to chapter 3. I hope we can cover at least 30% from this chapter today, and we continue tomorrow for the rest of the notes. Okay, for the chapter 1 is the introduction for the EE, and chapter 2 is the sustainable energy management setup. And then as the energy manager, you must to understand on how this price and tariff has been designed, or at least you get the idea to calculate the energy cost at least. And this chapter also cover on the demand. Okay, what's kind of the type of tariff, and you must understand how to calculate the cost of electricity, the cost for the maximum demand, and also tariff initiative by the government or by the utilities they offer to the consumer, so that they can respond to the tariff initiative and get more saving on the initiative or the percentage of the deduction on their electricity bill. Okay, so after that, the last part is to analyze the penalty and correction strategy. We have a connected load charge as the penalty. We have also a per factor charge as the penalty when certain criteria doesn't meet by the consumer, and TNB or utilities or energy provider can put the penalty on the consumer electricity bill, because there's the agreement in the early registration, and we must understand when we have drawn any kind of the for example, lower power factor in our house or in for the building, and we put some problem to the connection or to the system of the electricity supply, and TMB need to put some efforts and additional effort to correct the signal from our installation or from our building, so that they put the penalty for us if there is any abnormal reading from our side. Okay, effective 1st January 2014, the electricity tariff was reviewed. Okay, prior the electricity rate based on the utilities. Okay, this one is very important, and um, I want to stress out that in Malaysia we have we have Energy Commission, another department that control on the price for the electricity. Okay, before that before 2014 we have generation, the price, okay, the selling price. This one is the average selling price in 2013. Okay, and then this 33.88 cent per kilowatt hour, okay, is to support the generation cost for about 75%, transmission cost for 7%, and distribution cost for 18%. Okay, after that, government decide to increase the tariff to the 38.53 under the incentive-based regulation, so-called IBR. So what is IBR? Okay, in this slide, IBR to strengthen the following the economic regulatory framework for the regulating the TMB. So this IBR is under the Energy Commission to regulate the TMB with the proper framework and to measure the KPI of the TMB. Every single year, TMB need to fulfill the KPI that has been set under the incentive-based regulation or IBR. Okay, incentive mechanism to promote efficiency and service standard. So they put the standard service for the TMB or another utility to fulfill the efficiency level, and then the process of the tariff review, and they come up with the tariff review. If there is any kind of the changing from the generation, from the policy of the government, that's the review for the base tariff. To be reviewed every single 6 months. It's depending on the on the status of the policy from the government. Okay, that's the process for the creating regulatory accounts and its annual review process. Annual review process to the regulatory account. They have IBR account, the standalone account that has been reviewed every single year to check the performance of the utility, and based on what kind of the performance they should achieve every single year, and if they achieve this kind of the list of the KPI, and they have the ability, they have the promotion to get the revenue to receive the revenue from this regulatory account. Okay, IPR is the mechanism, method of the electricity determinations focusing on the efficiency gain structure. That is the IBR that cover all the things. All the things include the CAPEX and OPEX, the operational or capital cost expenditure and operational expenditure in the electricity supply, which mean all this setting for the base tariff. This one, the figure show the IBR structure for the base tariff. Base tariff, uh, which is set started from the 38.53 cents per kilowatt hour from the 2014. Okay, 2014 is the trial year for this IBR, and after that they consider 3 years for the regulatory period, and currently we have 2 regulatory period. So regulatory period RP1, so-called RP1 started from the 2015-2017. So all those criteria, all those expenditure under the TMB or the utility will be covered by this base tariff 38.53, including the salary of the staff, including the salary of the CEO and managing director of the TMB. So we can say that TMB as the confirmation of the revenue for the operational. Okay, so supported by this kind of the base tariff. From here, okay, they plus with the ICPT here, base tariff. Okay, so electricity tariff review based on the base tariff one, this one, and the imbalance cost pass through here, ICPT. What is ICPT? So ICPT tariff adjustment to reflect uncontrollable fuel costs and other generation costs. So different between forecast and actual cost procuring electricity that is beyond the control of the utility. So this ICPT will be shared to the consumer if the it depend on the generation sources price. For example, coal, LNG, gas, fuel, etc. So if the forecasting price is the current price is over compared to the forecasting price, and this charge of the ICPT will be charged on the billing of the consumer, electricity consumer. Okay, if not, if less than the forecasting value, then utility will reimburse or will pay the consumer or can get the discount for every single cent that they can set every 6 months. For example, last 6 months is they can measure the performance of the last 6 months. The price for the coal is lower than the forecasting one. Okay, so they can set the SCPT will be reimbursed or will be discharged to the consumer bill. Okay, within with the proper price for the per kilowatt. For example, to 0.02 cent per kilowatt. So they can charge, or so they can give the discount on this what we call it, on this structure, under the structure of the IBR system. And the other one is the base tariff. So from the base tariff, when we're talking about the base tariff, this one will be used by the utility. For example, TMB will be used this 38.53 cents per kilowatt hour to design their own tariff for every single consumer under the TMB. For example, okay, this one is the ICPT. Okay. Okay. CPT, under CPT, there has kecup. I will explain about the CPT first. Okay, ICPT, imbalance cost pass-through, there's two mechanism under the ICPT. So adjustment in the following 6-month period subject to the government approval. So every 6 months they can review the price for the coal and LNG and gas. Okay, if there is any changing for the price compared to the forecasting one, then they will adjust the following 6-month period for the ICPT tariff. So there's two tariff. One is the base tariff, and another tariff is the ICPT tariff. And generation cost adjustment. So this one is also based on the actual cost of the generation. So combine these two will be the tariff for the ICPT. Fuel, okay. Fuel components under the ICPT one is the pipe gas, coal, and the LNG. So this one is the forecasting price when they decide to design this base tariff after 2013. For the trial year, they use these numbers of the what we call it, the price for every single pipe gas, coal, and energy. So from the 33.54, they increase about 14.99%, or about 4.99 cents per kilowatt hour on this new average tariff started 2014. And what happened for the mechanism of the IBR? Okay, this under IBR for the base tariff, they have split into 5 components under the TMB. For example, here single buyer generation, with the generation single buyer generation. So this one is the breakdown of the price, base tariff price 38.53. They split into 26.38 cent for the generation. This one for the single buyer, this tariff for the transmission, and this one is the for system generation, GSO, grid system operation. And at that time for the 2015, they group the distribution and customer service to receive 8.25 cent per kilowatt hour. Okay, so under 38, the revenue of the TMB or the OPEX and CAPEX of the TMB is secure because of this tariff under the IBR. So prior to that, we hear about the losses of the TMB in 2010, in 2009, because the proper management of the base tariff is not clear, and the revenue calculation also was mismanaged. Okay, so this kind of the IBR will give a better mechanism for the TMB revenue. Of course, TMB is one of the company related to the government under the Khazanah, and most about 70% of the revenue will goes to the Khazanah, and Khazanah we pay the government for the any profits of the Khazanah. Under the Khazanah, they will give back to the government, and government will use this kind of the profit from the Khazanah to reinvest or as the money to drive the government operational costs. So from here, we can see that 38.53 KMB design the tariff for the domestic, and this value present the average one. Okay, average for the commercial, average for the industrial, 36.15, and the overall tariff must not exceed than this 38.53. Okay, under this one, for example, domestic, so there is a lot of type tariff, and under commercials, there's several type of tariff that's available for the consumer to subscribe, and for the, of course, for the industrial, there's the several tariff. Okay, okay, we learn about these difference of the tariff in the market right now, especially from the TNB. Okay, this is the increment, and for the regulatory period, this 2014 was the trial for the IBR, and started from the 2015 until 2017 is the regulatory period 1. And for the regulatory period 2, RP2, was started 2018 until last year. So what's the new features for the RP2? That's the support government's initiative and aspiration more efficient and the reliable electricity supply, right? And to put the commitment for the smart grid capabilities and tend to lower the efficient costs. Okay, additional key performance index KPI that have been put to the utility, for example, to support on the energy efficiency, to support on the renewable energy, so TMB. Okay, so we can see the commitments of the TMB on the EE. That's be one of the KPI. It's not easy to be seller for the electricity to promote the energy efficiency. The profit is come from the consumer. When consumer consume more electricity, then the profit will be more for the electricity provider. But it's hard to be the provider that you must fulfill certain KPI that to promote the energy efficiency so that consumer can reduce the electricity consumption. So that's the KPI. So we can see that TMB in their website, in the other way of the marketing parts, they put the effort to introduce the energy efficiency, the awareness for the energy consumer to lower down their energy consumption, right? Okay, that's one, the KPI, additional KPI for the TMB. Okay. It is also happen to the renewable energy promotion. So as the TMB or energy utility established in Malaysia for since 14 or 15 years, 40 years since the establishment of the LNN. So we can see that's the enough reserve for the TMB to supply the electricity to meet the demand from the consumer. But at this time, they have the KPI to promote the RE. So that's the dilemma. Of course, that's the dilemma from this KPI, but TMB have done very well on the promotion. Okay, we can see that's the efforts from the TMB on the RE and the EE program in Malaysia. And for the RP2 also the expression of the distribution network and customer service. Okay, so that's the story behind this. Um, I have this link to the Department of the Electricity Price in Energy Commission during my study, and I have reviewed all those things about the IBR, about the IBR, and especially for the parts of the revenue and how to calculate the revenue for the TMB. And this one is we have discussed together with the TMB and the Energy Commission that my finding first is to split the distribution network and customer service. Before that, they use the price cap to calculate the revenue for this one, but that's the obligation to split them, because distribution network have their own capacity for the COPEC and OPEC payments or operational costs. They cannot be like customer service that depending on the selling of the electricity. Okay, they have their fixed operational cost, and then that's why in the RP2 the distribution network has been split from the customer service, and they have their own revenue calculation to get sustained. And for the customer service, they have maintained on the price cap and based on the selling of the electricity. And it's too risky to put distribution network under the one roof of to be together on with customer service. And this distribution network must be standalone, have their own revenue calculation so that they can sustain with the operational and CAPEX and OPEX costs congruently. Yeah. So message structure also change. Okay, as I said just now, distribution and customer service has been split for the RP2. Prior to that, they has been managed together under the MESI. Okay, MESI is Malaysia Energy Supply Industry. This one is the structure. Okay, for the Malaysia, we have the MB generation IPP, and under the MESI for this IBR regime, we have SBO, ring fence for the SBO, single buyer operation, and GSO, grid system operator. So here there's the opportunity to get job from the SBO and GSO later on in the market. So you not just only target to get the what we call it, to get the job from the TMB. Okay, of course that's the opportunity to get involved in SBO and GSO. SBO cater on the bidding process in order to get the generation to supply the electricity to the transmission line. So they have cover on the bidding process here. So SBO will control everything. GSO is kind of the grid system operator. We have grid code under the GSO. So as the GSO person, you must understand the grid code, and then this GSO control on the transmission and distribution. The demand and other thing is under the GSO. And then for the RP2, they managed to get a split on the distribution and customer service here, so that the efficiency of the management can be increased, and to enhance the performance of the distribution. They have their own revenue process, revenue calculation, and customer service will survive on the selling of the electricity, and based on the electricity price and based on the design of the tariff that they put to the consumer commitment, so etc. So that's the RP2 structure. Okay, something like this. So the calculations of the revenue for the TNB based on the actual cost for the single buyer generation. Okay, the actual cost is related to the RCPT one when the price is they use the actual cost, they use the actual price on the generation side. But for the SBO, GSO here, SBO, GSO transmission and a distribution network, they use the revenue cap. Okay, that's the specific special calculation for the revenue here, and the price cap is depend on the selling of the electricity to the consumer. So what is the revenue calculation to the TMB? Okay, before that, we got to know that that's the increments of the new base tariff, but not affect the consumer electricity tariff, because TMB have designed the consumer electricity tariff and the average one is 39.45, and this base tariff have increased because of the single buyer operation, for the single buyer operation, GSO transmission, distribution, and the customer service. So the increment of this from the 38.53 to the 39.545 for the RP2. This one is examples of the KPI that must be achieved by the TNB. For example, customer survey, the SID one, interaction or interaction per minute, etc. That this performance must be achieved so that TNB will have the opportunity to get more revenue and to fulfill the revenue one. Okay, when they declare the WACC. Okay, weightage cost of capital. This the revenue, the block model under the IBR framework. Okay, so the OPEC, the depreciation tax, okay, and then the WACC return for the TMB, and then carry over amount from if TMB achieve the KPI, they can get the carry over amount from the previous regulatory period. If not, this one can be carried out. Okay, so this when the IBR have their own account, this carry over amount will be reimbursed to the TMB for the next calculation of the revenue requirement by TMB. If not achieve any KPI or certain level, they don't have the this kind of the efficiency carryover amount from the last regulatory period. And the important requirement for the TMB to get more profit for this model of the IBR framework is WACC and return. Okay, what is the WACC? Okay, so under the WACC, weightage average cost of capital. So when this WACC is higher, and the revenue will be higher for the TMB. If not, then they can enjoy the fixed revenue. But for this one, under the WACC, there is the after-tax cost of debt, cost of equity, gearing. All these things related to the stock market. You can view the performance of the TMB in the investing.com and other parts of the stock market to get this information. But every single year, every single 3 years or RP, from the RP1 to RP2, TMB will submit the proposal, the TMB to declare their WACC to be put on the calculation of the revenue. But for the RP2, they have submit three value of the WACC, low, medium, and high. Okay, and the last final decision by the government. So WACC have been set to 7.3 because RP1 they have enjoyed much profit when they set about 7.5%. So at that time, TMB have received um, more profit for the RP1. We can see how much their salary, their workers, engineers, or any workers under staff under TMB receive bonus 6 months, 8 months for the RP1. So for the RP2, this WACC has been reduced to 7.3 only, but they still have more profit on that. To know more about the setting of the consumer tariff, from the base tariff on how TMB should design, or this guideline will properly explain on how this consumer tariff will be setting up. Okay, you can refer to this guideline. For the summary of the RP2, this one is the revenue for the TMB, 135 billion for the RP, the target to RP2, and RP1 TMB have their revenue, the allowed revenue about 126. Okay, I remember that I just explained about the WACC one, when the WACC is lower and the revenue one is lower. But for the RP1, TMB have their allowed revenue requirement about 135 billion. Okay, so for the this one for RP2, okay, RP1 they have about 1 to 9. Okay, this time for the RP2, TMB has their additional revenue efficiency carryover from the RP1, so that they have the backup for the revenue. That's why we can see this the summary. Okay, the summary. Okay, for the key features. Okay, key features. So that remember about the WACC. Okay, WACC. So what happened to the TMB now? In last quarter, TMB has announced their profit for the fourth quarter about 600 million, and before that, so they have their less than 1 billion for the common quarter announcement. They have at least 1.2, 1.3, and last year, the last quarter, they have government, they have the consumer, and they make profit about 600 millions only. With the lower down of the stock market also from the 16 ringgit per unit, and now down to about 9 ringgit per unit of the stock stock market. The stock market now currently their effort to get increase the price for the stock price. Saya rasa about 11 ringgit per unit right now. Okay, a new project for the CAPEX and OPEX setting, and the 6-month review of the ICPT, introduction for the revenue adjustment annual, enhance the target under the new KPI setting. RP2 has been extended. For your information, this RP2 has been extended to 2021 because of TMB said the government has approved a 1-year extension of the secondary regulatory RP2 of the IBR for the 21. So they remain the same base tariff of 39.45 cent per kilowatt hour, and the scheduling of the maintenance, etc. So we are waiting for the RP3 coming to next year. Inshallah, I hope you understand on this kind of the IBR. Follow this information on the IBR so that you will be a good engineer later on this electricity field. Okay, remember on the economic one. So this IBR system consists of the base tariff, ICPT1, etc. Okay. Challenge and opportunity under this so that we can see here the Messi 2.0 will be drive. Okay. For the last Messi 0.1, so this one a target for the Messi 2.0. We can see here there's another opportunity for the gen teller here to be put as the generation to make it market more competitive. It's not the TMB generation only or IPP only, but that's the additional for the gen teller. Previously, the raw material is the monopoly one. So any IPP or TMB generation must buy the raw material, for example, coal with the TMB company only. But this time, when this come time to the liberalize the market, so we can see another company that will supply gas, for example, Petronas to supply to the IPP for the gas TMB, or Genteller here from the RE, can be the RE one. Okay, we can see the establishment of the movement of the RE in Malaysia can be one of the bigger generation, and to put them in the market as the competitor and supply to the grid system. So here the capacity market, the bidding one, okay, the wholesale market under the capacity under the open market over here. So everyone have their own chance to supply the electricity to the grid through the independent single buyer. Huh? The last previous one is the ring fence. Okay, still the staff, etc. from the TMB. Okay, for example, GXO, the staff from the TMB. Maybe that's the bias of in the selection one for the generation to get supply in the transmission line. But this time, independent single buyer and independent grid system operator will be more transparent on the division to make it possible for every single generation, include gen teller here, to supply the electricity on the grid. Okay, we have TMB transmission, TMB distribution, and this is very interesting part because of gen teller here and the alternative retailer and TMB have their own retail, and there is the competitor like we have telco right now, we have DG, we have Maxis, we have Celcom, etc. So that's the opportunity for the consumer to get their own selection for the provider here, or if they support to get a direct genteller here, for example, from the RE one, so they can select genteller to directly to supply. Or if you are understand about to secure the environment, and you can select the green tariff from the RE, from the PV. Okay, you can pay this provider to supply to your electricity to your house. Or you understand about the TOU tariff, which the different way on how to manage your own load and you can enjoy more electricity reduction over there. Again, you can select several parts or several scheme from the retailers, or you want to maintain the TMB from the TMB, and you just maintain from the TMB. That's the opportunity for the market to open the job for the graduates. Huh? With this kind of the structure of the MESI for the future, we can see that our graduate will have the opportunity to join the retailer, to join the gentailer, to join any parts of this regime for under the IBR system, and that's the Malaysia energy that's the Malaysia energy supply industry to be open-ended, and that's a good movement for the Malaysia to achieve certain level of the electricity supply, level of the efficiency for the electricity supply. Okay, if you know on how to design the tariff, you can work with the retailer, or you can be one of the retailer and register under the MESI, and you put your commitment. But this retailer have their own condition to pay for the TMB distribution at least 1% from the total tariff that you are designing for your customer. Interesting, right? Okay, this structure. So that's the opportunity for the peer-to-peer. What is a peer-to-peer? Your neighborhood can, your neighbor can supply, or you as the gentailer can supply your balance of the electricity consumption to your neighborhood. Or if you are you have the solar or PV, you can sell your electricity to your neighborhood. On how this will communicated, the communication system based on the blockchain technology. Okay, that's a good opportunity, and you as an engineer, I think that's this time to explore on the blockchain technology. Okay, prepare yourself to get this knowledge on the blockchain technology, because our system will move to this kind of the technology later on. Okay, to get the job, to get what we call it, skill on this kind of the technology is good for you. So future challenge: electrifications, digitalization, decentralizations, all key point for the electric vehicles, smart charging appliance, heat pump, smart meter, smart grid automation. So that's the key challenge. So if you want to get a good salary for the future as the engineer, you must have this one of this knowledge, electric vehicles, smart charging appliance, the electrification. For digitalization, smart meter, you must understand smart grid, automation system, IoT, Industrial Revolution 4.0. And if you doing on the tariff design, it's good to have that kind of the um, knowledge on how load will be managed, etc. Decentralization, for example, energy efficiency. So this subject we cover on the energy efficiency. At least you know what will be good for you for the future. Solar PV, distributed storage, battery, microgrid, demand response. Okay, so demand response is important. You must have at least basic knowledge on the demand response. Okay, peer-to-peer, P2P. That's all the challenge for the future. Try to get involved and have some knowledge on this kind of the key technology that has been highlighted by the government. Okay, how customer influence tariff designs. So incentive-based regulation here, IBR. Okay, cost of service study. Okay, tariff design. Okay, on how we can design on this kind of the tariff based on the base tariff. The kit here, on how we manipulate the presentation of this kind of cake. Okay, do tariff create bill risk for the certain customer? Are tariff understandable and actionable? So when we design tariff, customer must understand and actionable to respond to the tariff that we design or as the promotion tariff. Okay, so that's is when we look at the telco right now, the any promotion from the telco and very, saya pun dah tak boleh nak follow dah. If you can follow the telco incentive based on the price, etc. So it can be happen to the tariff by the provider after this. Okay, so we can get no more available tariff, TOU, ETOU, and another OU yang ada. So green tariff, etc. And then that's a good time as the young engineer to get know more about this kind of the technology surround you. Okay, okay, the TMB electricity. Let's move to this slide. So, or before that, is there any question? No questions. We proceed. TMB electricity bill component. So for the large consumer, so right now we are talking about the electricity bill. Just now that's about the IBR, and we know that's the base tariff for the TMB to design the tariff to the consumer. So now this slide, starting from this slide, we will talking about the customer after the meter. So about the meter, about the tariff on the consumer side. So main components of the capacity charge here, for the capacity charge of the maximum demand on kilowatt. For large consumer, for example, from the mid voltage or high voltage, they charge for the maximum demand kilowatt, and the other charge is kilowatt hour. Or unless for the other customer, for example, a residential or low voltage one, they only charge or TMB only charge on the energy consumption kilowatt hour. So there's another component for the charge. For the other charge, CLC, connected load charge, power factor charge for the penalty, and temporary supply where the equipment, or this is the common one, KWTBB, kumpulan one tenaga boleh diperbarui since 2010 I think, or 2005 ke. Okay, 1% charge for the late payment. Late payment 1%. Oh, okay, the customer can be categorized for this 1 until 7, domestic, okay, domestic, commercials, it's like a building, government sector, or another complex, hospital here, commercials, under the commercial. Industrial, from the manufacturing, factory, etc. Mining, okay, street lighting have their own structure of the tariff, or the street lighting have their own pillar. Okay, agriculture have their own design of the electricity top up and standby service. Okay, this one for the generator of the standby service from the utility. For the certain event, they call for the TMB to get the top up or standby service for any kind of construction, etc., or special event. They have a standby service or top up service. So that one is also have their own tariff, even though that is the one-off charge, and they calculate by using tariff. Commercial, you can read by your own. Industry, I have explained about domestic cogenerator. Cogenerator is mean the who that use a single primary energy source and have create their own electricity. They cogenerator, for example, palm oil mill, palm oil sector. They have their own regeneration of the electricity by using their waste, etc. So they get managed to have their own electricity supply. Okay, and also with the balance of the electricity consumption, they able to supply to the other factory nearby. So what is energy pricing and cost definition? The off-peak definition. Off-peak started that's the means for the TMB started from the from 10 p.m. To 8 a.m. Peak period started from 8 a.m. to to the 10 p.m. Monday to Sunday. The maximum demand is the large number of the kilowatt supply during any 30 minutes period in a month. In a month, there is the highest measure of the kilowatt of the power, and they declare as the maximum demand. So that's the available charge for the maximum demand to the customer or consumer from the mid voltage and high voltage, especially for the commercial and industrial. Public lighting months connected load charge. Okay, after this we'll be explaining more on the connected load charge. Okay, that's the penalty for the connected load charge. For example, we declare the maximum demand or demands of the power from our side as the customer. If there are any developments of the new development, so engineer or consultant will declare the demand of the power to the TMB. Okay, for example, 10,000 kilowatts for this kind of the new development. So after that, TMB will monitor this the maximum demand. If they do not achieve certain level, for example, 75% from the declared maximum demand, and that's the charge from the TMB, so-called connected load charge, CLC. And this consumer will pay 8.5 ringgit per kilowatt that they doesn't use or not achieve the 75%. The detailed calculation will be explained in the next slide, if I'm not mistaken, inshallah. This one is the definition for the voltage. Low voltage, medium voltage, high voltage, and ultra voltage. That's the value for the high voltage. Okay, over than 33, they call it as a high voltage, and for the maximum, the medium voltage, from the 1 kV to the 35 kV. And in Malaysia, as you know, that we have 11 and 33 kV for the mid voltage, and the high voltage tapping from the transmission line, we have 132 kV until 200 something kV. That one is for the high voltage. So the industry or the factory that needs more voltage for their system or appliance or equipment, they can tap from the transmission line and receive the type of high voltage tariff from the utility. And the rest, we receive the mid voltage, for example, C1, E1 for the commercial and industry. So let's move to this slide. The following tariffs is available right now in the market from the utility, especially from the TNB. So for domestic, that's the tariff A, okay. Tariff B for the low commercial, C1, C2. This one is for the medium voltage, but for C2, that's C1 is the flat tariff, which is there is the flat price for the whole day. They will charge based on one price only. And for the C2 different, they call it as TOU, time of use, because the peak price and the off peak price is different. Okay, so remember the definition for the off peak, the started time for the off peak from the utility is from 10 p.m. to the 8 a.m. That's the another price for the off peak, and the other price for the peak different to the off peak, and maybe the peak price is higher compared to the off peak price. Okay, for this customer that subscribe the C2, they are advised to manage their load, so that the peak demand will be reduced when they able to shift their operation from peak to off peak. And it's happened also to the industry, which the low voltage tariff D, and E1, E2, and E3 represent the mid peak, and this E2 represent a mid peak. This one is the flat tariff, general industry, and then off peak and peak. This one is TOU for the industry, and the high voltage consists also TOU, which the different price compared to the E2 and E3, because E3 is tapping from the transmission line, and the price, the cost to develop the substation or station to get the 132, for example, is more higher compared to the E2 or mid voltage. So that the price for the electricity or consumption of the electricity more lower compared to the E2. Okay, for example, the factory of Siemens factory, another one is the metals. Okay, metals industry use this E3. Most of them use E3 because of the equipment of the system is require more voltage. And okay, the other tariff, for example, mining have their own tariff, agriculture, etc. Then that's the structure for the domestic. Okay, this one for the residential, we call it as block tariff. Why block tariff? Because of this band. Okay, the block from 0 to 200, that's the different tariff, every single block. Block 2, block 3, block 4, block 5. And average of them goes to 36 point something, or certain value for this one, and reflect to the base tariff that has been set under the IBR. It's not exceed than 39.53. Okay, I think that's all for today, because I have another appointment in 11:45. We continue tomorrow. Can Inshallah.
Baik, doktor.
Okay, doktor.
I hope you enjoy the class. Is there any questions? Put it on in our group, okay? So that I can reply to all. So thanks. That's all for today. Okay. See you tomorrow. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
doktor.
Thank you, doktor.
Welcome.
Waalaikumsalam.
Thank you, doktor.
Thank you, doktor.
Sorry ya.